will now be recorded.
Yes. So hello everyone. So in today's session, we'll be discussing regarding front-end demo training. So demo in the sense, what we'll be doing is we'll be making you to understand what is VLSI. Okay, what are the different domains are there in VLSI? There is front-end domain, back-end domain. Okay, so in how to choose, either you want to enroll for a front end course or a back end course, I will tell you in a brief. Okay, and also we'll understand what are the job opportunities present for the front end as well as for the back end. And in a we'll take one means in a SOC, right, in a project, what I'm saying, in a project where the front end role comes, where the back end role comes, we will discuss regarding that. I'll also discuss regarding what are the institute facilities provided. Okay, so and yeah, what are the institute facilities provided? How institute helps you to in getting a job? All those things I will be explaining in today's demo session. Okay, fine. So during this demo session, if you have any doubts with respect to the demo topic, right, you can ask me. You'll be having some other personal questions, means personal in the sense like your career oriented questions you might be having. Okay, so those questions we can discuss at the end. Actually, at the end we'll have 15 to 20 minutes time, so where you can discuss your doubts. Any other doubts are there apart from demo, all those things we'll discuss. Is it clear? Okay. So agenda for today's topic is we'll be going through what are the courses that are going to start from today. I'll be giving you institute overview as well. Okay, so that's where I'll be telling you facilities provided by institute. Then I'll be going through understanding of electronic systems. Okay, so what do you mean by understanding of electronic systems is you take any electronic devices present. It might be laptop, mobile phone, projector, washing machine, right? How the system actually works. What is hardware, what is software? We'll be discussing there. Okay. Then we'll understand difference between VLSI and embedded system also. We'll also understand VLSI design flows. See, VLSI design, right, can be done in two aspects. One is ASIC design flow, other one is FPGA design flow. I'll be going through what is ASIC, what is FPGA, job roles, all those things we'll discuss. Then we'll come to the two domains of VLSI, that is front end and back end, where we'll be discussing what is front end, what is back end, its job roles we'll be discussing. Then we'll come to skill sets required for a candidate to choose which domain he wants to enter, whether a front end domain or a back end domain, and how VLSIGuru helps you. So those, and what are the skill sets required for a candidate, we'll be discussing here. And we'll also help you to choose the right domain also. So I'll be telling you about institute facilities, how to prepare for the jobs, why career in VLSIGuru, placements, and any questions you have, we'll discuss regarding that. Okay. So course that are starting today is basically front end training for freshers. Okay. Means front end training for freshers, or you might come across names called as functional verification training, design verification training, all are one and the same. Okay, front end training for freshers, functional verification training for freshers, design verification training, all are one and the same. Is it clear? And along with that, we'll be starting with physical design, PD. It is backend actually. PD is part of backend flow. Okay, DFT, it's also part of backend. Okay, these are the three courses which are starting today. I mean today in the sense demo sessions are going to happen today and tomorrow. Okay, so in that I'll be taking front end demo sessions for freshers. Okay, so respective demo session, that is PD and DFT, will be occurring. If anyone is interested, you can reach out to institute, means admin. You guys have the contact numbers, right? So you can reach out to them and you can ask saying that I would like to join for PD or DFT demo, and you can get the links for that. Okay, fine. So institute overview, if I come to institute overview, right? So VLSI Guru is being part of training the candidates to get into industry from past 15 years, 15 to 20 years. Okay, so we have trained a lot of, means every year we are starting 2 to 3 batches onto jobs. Okay, it will be either, means we will be providing the job placement support. See, basically this front end demo training for
Your voice is breaking, sir.
Yeah, you are not audible now.
online guys. Am I audible?
Yes, now it is audible. Before voice was breaking.
Okay. Okay. Yes, now I'm audible.
Yes, sir.
Yeah, I'm
Yes,
sorry.
sir.
Actually, there was some network issue. I just reconnected. Okay. Uh, See, I have not explained anything. What I just told was in front end demo session, right? Sorry, in the front end training, we'll be discussing regarding digital design, Verilog, system Verilog, and UVM. Okay. Along with this, we'll be discussing regarding one important editor which is used in every industry in Linux, that is GVM actually. Okay, so even in our discussions on Verilog, system Verilog, UVM, and so on, we'll be discussing regarding, we'll be using GVM itself. Okay, so that you'll be having hands-on experience on the editor prior to your you getting a job. In a job, it will become easier for you to cope up with the things. Okay, so once we are completed with these topics in your front-end training, you are basically job ready. What do you mean by job ready? As a freshers, basics is what is needed to get into any industry, any VLSI companies, semiconductor companies. So you are basically job ready here. Okay, so what we'll be doing is, once these topics are done, we'll be putting you guys into the job support group. VLSIGuru has dedicated job support group for every batches which is gonna start, like your batch which is gonna start on February, or that is March basically, right? Next week onwards, March it is. March. So you'll be put into a March job support group once you have completed UVM. These are the basics needed once you complete UVM. Okay, so what you need to do is, to get into job support group, you have to be able to uh, submit assignments for respective subjects, score more than 75% in each subject evaluation. Meaning what? Digital design, GVM, no evaluation, it's just a tool. Digital design, Verilog, system Verilog, UVM. There will be evaluations. Evaluations with respect to written test, plus mock interviews will be there on each subject. Okay, so you need to be scoring 75% and above. It might be online, offline, both the candidates enrolling for front end training basically. Okay, so once you meet the criteria, that is the evaluation standards, you will be put into the job support group. The reason why we are doing this, because see, uh, means in like, it's not like a person having no knowledge can get into a industry. Do you agree? At least 70% knowledge it should be there on a subject. Then only he or she can get into the clear the interviews and get into the companies actually, right? So we are also maintaining the same standards itself before we put into the job support groups. So after this, whatever we are going to cover, that is, uh, let me I hope everyone have gone through the front end course topics, right, which is there in the VLSI Guru website. That is AXI protocol training. Let me just show you this so that you can also go through it in your convenient time. VLSI design and verification course. Yeah, so these are the topics which I was speaking regarding. Digital design, Verilog, Verilog design and verification using multiple projects. Basically, Verilog in the sense, this Verilog deep dive is all about theoretical. We'll be discussing regarding theory concepts. That is, different Verilog constructs, present data types, functions, task in Verilog, how to implement, module, how to write. All those things we'll be discussing in this aspect. So whatever you learned in Verilog language, right? That language you'll be implementing in multiple projects. So the projects are, these are the projects what you'll be implementing. You can go through this, okay? So then we will be discussing regarding system Verilog, UVM constructs. So once you're done with UVM, you're put into job support group. So parallelly, you will be learning Linux commands, So why we learn Linux? Because see, in every industry, right, they work on the projects on a Linux environment. Okay, so we teach you regarding what are the Linux commands present, so it will help you in your job. Next, we'll be discussing regarding one of the important protocols in semiconductor, that is an on-chip protocol. It's called as an on-chip protocol. What do you mean by on-the-chip protocol? Basically, chip. Suppose you take this is a chip. Chip in the sense what? Your Intel processor chip. You think Intel processor is a chip, right? That chip has a ARM Cortex processors, and there are some subsystem blocks present. Some other blocks are present. Display block, USB blocks are present. So block to block communication, we call it as on chip protocols. Block to block, when one component and another component, that is block to block communication is happening. Whatever communication, it's not English or other languages. It is data communication is what is happening between one block to another block inside a chip. So that inside that block, when data communication happens, that type of communication, that type of the communication, there are some rules present actually. That rules what we call as a protocol. Since it's happening on the chip, it's called as on-chip protocol. So one of the common on-chip protocol is AXI protocol, which every ARM processor will be having it in your chip. So we'll be discussing regarding that AXI protocol. Theoretical will do, plus practical also will implement the AXI concepts. Then we'll be discussing regarding ASIC verification concepts. Then we'll go to one very important project in this is one very important project is Ethernet MAC project. This is the industry standard project actually. So what do you mean by industry standard project? Even in your laptop, there is something called as Ethernet MAC. Okay, so we'll be learning regarding how to verify that Ethernet MAC using system Verilog and UVM based verification environment. Is it clear? Then we'll be discussing regarding some few RTL debug concepts, SOC verification concepts, ASIC flow, Perl, or basically we'll be discussing regarding Python scripting. For a front end training, right? Python scripting is what is needed actually for a front end. For back end, TCL and Perl is required. Okay. Then you'll be having soft skill training as well. Soft skills training, it will be going on a weekly basis, starting from the day one. It's not like at the end we will do soft skills training. Starting from the day one, weekly once, you'll be having a soft skill training. What is soft skill training? It will help you to, it will help you in communication, basically. Help you in communication, help you in get confidence. Is it clear? The course assignments, as I told you, in each module, we'll be having an assignment. Digital topic, Verilog, System Verilog, UVM, AXI, Linux, Python. We'll be having assignments. Okay. So to solve these assignments, VLSIGuru provides dedicated lab support or assignment support, we call it as. Okay. So this lab support or assignment support will be there every day, starting from digital to Python. What do I mean by that? Morning you will be having theory, afternoon you will be having the lab, where the trainer will discuss with you guys the assignments to be done on that day. Understood? So assignment and the theory, right, will be going side by side. Like in theory, if you complete one topic, let's say combinational logic, half adder, full adder, half subtractor, full subtractor, you have completed. Respective assignment you have to complete in your uh, assignments part. Okay. Now in digital topic, right, I know most of you have already completed your engineering, or you're in your fourth year of engineering. Some of you have done higher studies also. I know that you guys are already familiar with the digital design. Now question comes, why to do it again? Right? Do you agree? Why do I need to spend time again to do it? Because VLSI is all about digital. VLSI is not all, is all about good understanding of a digital circuit. It might be front end, it might be a back end. Digital circuit becomes a very base, very base level it is. Okay, so to get your understanding even more stronger, we are doing this digital design. Along with that, the assignments what is present, it is industry level assignment. Means what do you mean by industry level questions we are asking is, it might be product based, service based companies. Every company, whoever comes to VLSIGuru, right? We are having, means the questions we are taking from them and we're implementing as the assignments. So most of the digital questions, it's a gate level question actually. Getting my point? So it will help you to understand the concepts even more clearer and help you to solve tricky questions which might come up in your interview based. See, I'm not saying that if you complete digital design assignments, the same question they will ask in the interview. I'm not saying that. Nowhere it happens. It's not. It is not a engineering exam, right? Where the same question they will ask. It's not like that. Concept wise, it will be same. Question will vary. Concept wise, it will be same. Question will be what? Varying it. Understood? So these are the topics what we'll be covering in the front end training. Do you have any questions in these topics? What are the tools we are going to learn? Okay, let me tell you. Tools used as part of design and verification training. See, when I say design verification, it's also meant front end training or functional verification training. Okay, tools which are used is Synopsys VCS, Cadence Exilium. Means VLSIGuru has these tools. Licenses are there. Okay. Siemens Questa Sim. Questa Simulator. Okay. Along with that, we will also give you access to Model Sim. We'll also give you access to EDA Playground. Now question comes, sir, do I need to learn all of these tools in order to get a job? Question comes, right? Do you agree? Yes or no? Not needed. See, not needed. There are still a lot of tools actually. There's still a lot of tools present. But in industry standard is these three tools: Synopsys VCS, Cadence Exilium, Questa Sim, Siemens Questa Sim. Now question comes, should I learn all of these three tools, sir, before getting into the job? Not needed actually. Why? Because once you are thorough in your subject, right? Once you're thorough in the subject, learning tool is a hardly 2 days to 7 days only it will take. Maximum 1 week. Minimum, very minimum is 2 days you will take to learn a tool. Basically, what you learn a tool, what you should learn in a tool, basically how to run the code. So to running a code, right, there are 3 steps involved. To run simulation, see basically what to learn in a tool, what to learn in a tool. Question comes. So first is what? How to run simulation. Second is how to see the waveform. Third is how to debug the issues. These are the 3 things what you need to learn in terms of tool. Okay, now to run the simulation, right, you're having commands such as compile, elab, and simulate. These are 3 steps: compilation, elaboration, simulation. Wave to see the waveform GUI we use, right? Graphical user interface of the tool we use. Basically, we open the tool and we see the waveform actually. Yes or no? To debug, same thing, we use GUI. We open the tool. We in the waveform you see the issue and you debug that issue. Getting my point? So these three things can be learned can be learned just by just by doing doing 2 to 3 simulations. Means 2 to 3 times you run a simulation for different scenarios. You run the simulation for 2 to 3 times. You will, in each tool you learn, you will get familiar with the each tool. Getting my point? Okay, but to learn a subject, it will take 1 month, 1.5 months, or maximum 2 months it will take to learn a subject. Digital design 1 month, system Verilog 2 months, Verilog 1 month, UVM 1 month. Getting my point? To learn subject, it will take more time. But to learn a tool, it hardly take minimum 2 days, maximum you take 7 days it will take. Maximum. Getting my point? Okay. So what industry is looking is, out of any one of these tools, be familiar with one tool. Getting my point? What do you mean by be familiar with one tool? That is, in the back of your hand, you should be able to do all of these three things given any scenarios. Example, if you take synopsis VCS, you should be knowing how to run the simulation, how to see the waveform, how to debug the issues. My point. See, then that is what VLSIGuru does. We will take one tool, will teach you everything. We'll give you access to the remaining tools. You can explore that. Or explore in the sense, we'll have dedicated sessions to explore that. But 1 or 2 sessions we'll have, that's it. Subject wise, we'll go in depth. Getting my point? So what do I mean by that is, in Verilog, entire 1 month of Verilog, we will do using model sim. Verilog, I'll say Verilog. Verilog will do using model sim. System Verilog and UVM, we will do using Questa sim. UVM is done. Right? AXI, Ethernet MAC. We will do using Synopsys VCS. We'll have one dedicated session, 1 or 2 dedicated session to also discuss regarding Exilium as well. Means Cadence Exilium. Understood? Getting my point? So get familiar with one of these tools very much. Means if you are familiar with model sim in Verilog, right? Questa sim is very much same. I'll tell you, Questa sim is 100% similar in GUI, command execution, everything is same. Okay. Similarly for but then question comes, sir, why are we using Questa sim in SV and UVM? Why not model sim itself? The reason being is, model sim doesn't support system analog and UVM simulations. That is the main reason. Questa sim supports SV and UVM simulations, so we are going with Questa sim in terms of SV and UVM subjects. Okay.
One question,
And
sir.
EDA
What is
playground, just give me a minute, let me complete. And in EDA playground, it's an open source actually. Open source in the sense, what you can log into your own mail ID and you can run all of these tools there. But since it's an open source, not all the features are present. Limited features are present in terms of simulation, because it's an open source, right? So limited features are present. Yeah, please tell me, what is your question?
what is the difference between Verilog, system Verilog, and UVM?
Yeah, I will tell you the difference. Okay. Difference between Verilog, system Verilog, and UVM. First difference is SV and Verilog. It's a language actually. Language means what? They have their own data types, function, task, declarations, syntax wise they will vary. That's what language is all about. Second, UVM is a methodology. You can treat UVM as a Python. UVM is a Python, and SV and Verilog is like C, C++ languages. Where Python, it has a lot of methods, right? You might have come across Python in your engineering background or in your earlier subjects, right? Python is like a what? It's like a methods. It has only methods. Python, yes or no? SV and UVM is
Yes, sir.
like C and C++ languages. Second thing is Verilog is purely for design, purely for design purpose, designing of ASIC chips. When I say ASIC chips, application specific integrated circuits. Example is a mobile phone. It's a application specific. My mobile phone, which has a bionic processor, it is a application specific for mobile phone actually. Means that chip is only meant for this mobile phone operation. I cannot remove that chip from my mobile phone and keep it in my laptop and use as a laptop. I can't do that. So ASIC chip designing is done using Verilog. Basically, Verilog and system Verilog, I'll say SV and Verilog. Okay, I'll keep like this. See, Verilog is purely for design of ASIC chips. SV also can be used for designing ASIC chips, but SV was purely meant for verification aspect. What do you mean by verification? Test bench aspect. Now, what is test bench? In engineering point, you would have come across IC testers. IC tester, one circuit used to one instrument used to have IC tester. Yes or no? So where you keep any IC on that IC tester, that IC tester used to say whether it is faulty or whether the IC is a faulty or whether it's a good IC. Yes or no? That IC tester is similar to test bench. Okay. Now where whatever the design we will implement, the design will be kept upon this test bench and done the simulation to check the design features. Understood? So test bench is like a platform which is nothing but a code. Platform which is nothing but a system level code. Okay, upon which we keep the Verilog designs to test it. How we are going to test it? By generating the inputs and monitoring the outputs. Is it clear? So, but some aspect of the system Verilog also allows for designing purpose as well. Okay, some features of SV can be used for designing as well. That's what I'm trying to tell. UVM is a methodology. I told you, is a methodology purely built means UVM methodology is purely built using SV, system Verilog. Means whatever you see in UVM, it's all about SV code. It's all about SV code. So in system Verilog, if you are 100% thorough on the subjects, UVM will be like very easy. UVM will be very easy to understand. Very easy. It will be very easy. Is it clear? So, but UVM was purely developed for test bench, for implementing test bench. Understood? So where UVM provides industry standard level, UVM provides industry standards for developing test bench. Now, what do you mean industry standard? You go to Qualcomm, the UVM test bench. What do you see? That will be a standard for every product-based companies like Qualcomm, Samsung, Nvidia. You list down, right? Cadence, Synopsys, etc. Is it clear? The same standard test bench will be used in everywhere. Okay, so that standardization is what we will be learning in UVM. What is the standard present? How the test bench standard is present is what we will be learning in UVM. Okay, I hope this is clear here. Difference between Verilog, system Verilog, and UVM.
Yes, sir. Thank you.
Yeah. Anything else you would like to ask? Anyone would like to ask? Offline, online?
So they mentioned the subjects as you mentioned, but the extra one is CMOS.
CMOS is not necessary for a front-end verification. For knowledge point of view, you can learn CMOS. Why? Because CMOS, FinFETs all are needed for a back-end engineer. Okay, but knowledge point of view, you can learn CMOS. No, nothing wrong in that. Okay, you can ask VLSIGuru; they'll give you that access. Okay. Yeah. Anything else? Okay. Shall I continue? Okay. So I hope you guys are familiar with the subjects what are being taught as part of the course. You all can go through this online. It's there in online actually. VLSIGuru online website, right? It is present. You can all go through this as well. Okay. So one thing I would like to make clear in this course, I will tell you wherever you take this course up, don't focus on the tool. As the industry expert, I'm telling you, do not focus on the tool actually. Mainly focus on the subject. Subject is a key actually in getting placed. Tool you can learn anywhere. Tool you can learn even in the industry also. After getting into industry, getting into a project, you can learn tool. Why am I saying this? Because in interview they won't ask this. Second thing is based on your company what you join, the tool will depend. See, one company can use Cadence, another company can use Synopsys VCS, right? So it depends. All those things depends. Is it clear? So focus on the subject mainly. It might be front end, it might be back end. Anywhere, focus on the subject. Subject export when you get, it will be easier to understand the tools. Okay. So let us go through understanding course starting today. We have learned, right? Understanding electronic system. Okay. So electronic systems are what are the examples of electronic system? Can anyone tell me, online or offline? Anyone? Examples of a electronic device, electronic system.
Washing machines, phones,
Yeah, washing machine, phones, then projector. Whatever, what is the projector? Where you are seeing the screen, right? Projector. It's also an electronic system. It also has a processor in it. Sir, no. Washing machine also has a processor. My
Consoles,
laptop,
gaming consoles.
yeah, gaming consoles is a very good example. Where the it also has a processor, GPU, and all, right? Laptop, mobile phones, all are example of an electronic device. Okay. Now, if you take example of a mobile phone, right? What all things will you see in a mobile? What all things you will see once you break open a mobile phone? I'm saying, meaning what you open the back cover, what you see is you see speaker, you see the processor, you see the battery, you see some power management units present, you see the earphone jack, you see the antennas, you see the flashlight, camera modules, display modules, etc. Right? Lot of things you see. Whatever you see, once you break open your mobile phone, that is called as a hardware. Now, mobile phone or any electronic system is not only built using a hardware, it also has something called as software also. Software plus hardware makes up your electronic device. Hardware gives you the features, software gives you the optimization for those features. Right? So, what all things make up a mobile phone? Hardware. Whatever you see, it's called as hardware. Chips, processors, screen, USB port, camera, sensors, audio ports. Right? All those are hardware. Display modules. Whatever you see the display here, right? Display in your mobile phone. It's a hardware actually. Then there are some things which you don't see also. They are nothing but firmware, operating systems, and applications. Applications, you see the application image, but you don't see how it is. You can't see how it is coded, right? The code you cannot see it. Yes or no? That's what we are saying is we can't things which we don't see in a electronic system. Firmware, operating system, and applications. So firmware is something but called as the drivers. Operating system examples are Android, iOS, Linux, etc. Windows. Applications are nothing but the whatever you guys are seeing in my screen. That is Microsoft PowerPoint is application, right? The means you join this session. Go to meeting application. Chrome application. WhatsApp, Instagram, Facebook, media applications, right? So mobile phone, right? In total, they are having 4 layers actually. First layer is the hardware, second layer is the firmware, third layer is the operating system, fourth is applications. So hardwares examples are processor, camera unit, sensor modules. Who develop it? VLSI engineers develop it. So our role comes in the hardware development of an electronic system. Okay. Firmwares, drivers, embedded system engineers are responsible for developing it. These drivers are nothing but assembly level language code. Drivers are nothing but assembly level language code developed using embedded C. Basically, it's a C language itself where there are tools present which converts C to assembly. So, who's responsible for developing it? Embedded system engineers. Now, we are not embedded system engineers, right? So, we don't need to worry about drivers in a hardware. Drivers in an electronic system, we don't need to worry about it. But in one point of your verification, something called as a SoC level verification, subsystem system on chip verification, that is Qualcomm Snapdragon system on chip verification as an example, you will come across something called as a driver. The embedded software engineer will give you driver codes, but you don't need to worry about how to write it, how to debug it, all those things you don't need to worry about it. You just have to take it, use it. Any issue comes, report it. Is it clear? So operating system, you will never come across it in your working. The example of our operating system in electronic devices: Android OS, iOS, Windows, Linux, are the examples. So who develop this OS? Software engineers will develop the OS. Applications examples are Google Pay, Phone Pay, Maps, Microsoft PowerPoint. So who develop it? Software engineers or app developers will do the development of these applications. Out of all of these 4 layers in an electronic system, such as a mobile phone, you are only worried about the hardware point of view. Okay, so what do you mean by hardware point of view? You all know that your laptop has something called as a USB port. Yes or no? USB port it has. Do you agree? Why it is used USB port? What are the applications of the USB?
To transfer data from one medium to another medium.
To transfer media from one medium to another medium. Example is what? Memory. I mean, pen drive. Your pen
Yes.
drives. Pen drive is a memory actually. Where your laptop to your pen drive or pen drive to your laptop. The data you need to exchange. Meaning a movie files you need to exchange. You do it through USB port. Right? Yes or no? Second application is a printer. Printer application. Printer also is a USB port, happens to USB port itself. Where whatever you suppose I want to print this PPT, what I'll do? I'll say print. So my OS will take care of sending that print data into the USB and USB to the printer. Is it clear? Okay. So you will be responsible for developing that USB, not the port. I'm not saying the port. Basically, in your SOC, right, there will be something called as a USB controller will be present, which is responsible for taking the data from the memory and sending it to the USB port, USB physical layer. So you will be doing, you will be verifying that USB controller operation in your work domain. Understood? Any questions still here? Okay, I hope no questions. I'll proceed further. So electronic system, right? The 4 layers what we saw. Let's take one analogy to understand how it works in a electronic system. The analogy here is bus with passenger. There's a bus present and there are passengers in it. Okay, your name? Nitesh. Suppose let's say Nitesh is one of the passenger in the bus. I'm just taking one example. Suppose let's say Nitesh is one of the passenger in a bus. So what Nitesh will do when he wants to get down at a particular stop, Nitesh will first intimate that he wants to get down to the conductor. Conductor, when that is through buying a ticket actually. That is when Nitesh buys a ticket, bus ticket. So he'll intimate to the conductor saying that I want to get down at point B. What conductor will do whenever the point B reaches, conductor will inform to the driver, bus driver, that please stop here. There is one passenger who needs to get down. Do you agree? This is a flow. What is there in a where bus with passenger? This is a flow. What is there? So here bus is like a hardware. In this scenario, bus is like a hardware. Okay. Drivers are like what? Firmware. The bus driver is like a firmware. Bus conductor is like operating system. Bus passengers are like applications. So when an application wants to do any operation, the application needs to follow the same procedure as what Nitesh has followed. That is, the application doing a particular scenario, that scenario need to be communicated to the operating system. Operating system communicates that scenario to the firmwares. Firmware then communicates to the hardware. Then the hardware does the actual change in your electronic system. Example for that is what? Example for this is, example is Consider display brightness change operation, which every one of you have done this in your mobile phone. Do you agree? Mobile phone or on your laptop, we have changed the display brightness, right? Let's take an example of from 100%, I need to change to 50%. You would have done this operation? Yes or no? What will you do? Will you break open your mobile phone and will you take the power management unit and will you write there 100? Will you erase it and will you write 50 on it? My question is, how will you change your display brightness from 100 to 50%? Will you break open your mobile phone? That is, throw your mobile phone, it will break, you'll open it, there will be power management unit present. In that power management unit, you will erase that 100 and you will write 50 on it. Is that how you do it? No, that's not how you do it, right? If you break open, what will happen? That will be the end of your mobile phone actually. Yes or no? What do we do? We use step number 1. What we do is open the application. Now what application? Settings is application, right? Settings. So no, in settings, what you do? Navigate to something called a display and brightness, might be there, right? Navigate to display and brightness option. Yes or no? Then what you do? Change the parameters. Basically that scrolling option, something might be there, where you will scroll it from 100 to 50%. Change the level, brightness level to level from 100% to 50%. Do you agree? This step number 1. This is what you do. This is what you will do. Yes or no? Now this operation, this command, what is the command? Changing the brightness level from 100 to 50%. This command, it will be communicated to the OS, your device OS. Example, mobile phone, Android OS or iOS. Windows means laptop means either Linux or a Windows or Chrome OS. Yes or no? So step 2, what is that? OS communicates this change in brightness level to drivers. Step 3 is what? Drivers will communicate this change to hardware, that is power management unit, PMU. Step 4 is what? The hardware, I'll say hardware. Okay, let's speak with respect to the 4 layers. Hardware, what will do? Hardware will change the register value from 100 to 50. Basically your design hardware will be having some registers. The register value will be changed from 100 to 50. Then your brightness level will decrease, means it will go to 50%. Now all this happens within a second, within a millisecond it will happen. Is it clear? So this is how 4 layers will interact in your electronic system to do any operation. It might be any operation. This is what it will do. One example of the operation is changing the display brightness operation from 100 to 50%. One example. Similar operation will happen even in your when you transfer the data from your laptop to pen drive to laptop. You will use applications to do that. Internally, those commands are given to OS. OS gives to driver. Driver gives to hardware. So in terms of data exchange in your pen drive, right, through USB, USB drivers will come into picture. USB drivers USB drivers development, embedded system engineer will take care of it. You need to worry about USB controller able to fetch the data from the memory and send it to the peripheral, such as USB port. A USB port is a peripheral. It is present outside your chip actually. Means it is present in your laptop. Okay, suppose if this is your laptop, suppose if this is your laptop, this is a laptop, your system on chip SoC, that is my laptop is a Intel Core i5 processor. In my laptop, the Intel Core i5 will be present somewhere here, somewhere in the between it will be there. I'll draw it a bit big because I need to it won't be this much big, it will be very small, but I want to draw big because I need to write some things inside. So this is where your SoC is there, Intel i5, or in general I will say system on chip SoC, who is the brains of your entire laptop. This SoC will be having processors, CPUs, GPUs will be there. Okay, I'll call it as I'll draw like this. You'll be having CPU subsystem, I'll call it as CPU SS. You might be having single core, multi-core CPUs. They call it as, right, multi-core CPUs, meaning what, multiple processors will be present. Four core means four ARM processor will be present. That's what is called as four core or multi-core. There'll be GPUs. There'll be memory SSD will be there outside actually. SSDs means your SSD, right? Whenever you purchase a laptop, you see that you want a 1 terabyte SSD. That SSD is not present on the processor. It will be present outside the processor because the SSD is very big, right? 1 terabyte means it's very big space it consumes. So they are present outside the laptop. I mean outside the SoC, inside a laptop. SSDs will be there here. So you'll be having some ports also present. Ports also present here, right? Such as USB port, one example. USB port is one example. In this USB port only, you will connect the laptop. You will connect the pen drives, right? This USB port will connect your pen drive. Something like this, pen drive will connect. Right? This is pen drive. Now this guy will be having this SoC, right? Will be having a peripheral controller. What is peripheral? Communication to be happening from on the chip to the external is called as a peripheral, such as USB controller will be there here. I will draw it here. Okay, I'll draw it here. There is something called as USB controllers. Why USB controller? Because it's a USB port, so USB controller we'll use. USB controller. Okay, now here to here connections will be happening through some copper wires. So again, this USB controller, when you use applications, and when you say that you want to transfer the movie files from laptop to pen drive or pen drive to laptop, take an example of pen drive to laptop, you want to transfer. What happens? That command from your applications reaches the OS to the driver to the hardware. So what it happens is, the command goes like this. The CPU issues that command saying that read to the USB controller. It says that read the pen drive data, that is the movie data, read it. The command goes like this to this pen drive. So what pen drive will do? Pen drive will send the data, that movie data, it will send to the USB controller. USB controller will send it to this. Again, in between there will be something called as a memory subsystem. Okay, the USB controller will send the data to the memory subsystem, and the data will be stored into the SSD. Is this clear? I'm just trying to give you a top level understanding here. Okay, I'm just trying to give you a top level understanding. Is it clear? Did you understand this? Anyone questions? Do you have any questions online? So in all of these things, right? In all of these things, I will introduce you few concepts here. In all of these things, this communication, whatever the communication I'm going to mark now in red color, okay? This communication, it is called as a peripheral communication. So we use peripheral protocols such as USB protocol. We'll use USB 3.1, 3.2 is the latest version. In your mobile phone, and you see laptop, USB 3 will be there, or USB 3.2 will be there. Yes or no? So this is called as a peripheral communication. So we use peripheral protocols. Whatever the communication is going to happen here, that is CPU to the USB controller, it is called as a on-chip communication, because USB controller is present in the SoC, CPU subsystem also present in the SoC only. So on the chip blocks are called as on-chip communication. So we use on-chip protocols. Example is AXI, APB, AHB, ACE, AEC. Lot of protocols are there. Understood this point? Okay. So in our course, right, we will learn regarding this AXI protocol, on-chip protocol, one of the very important protocol which is used in every SoC. It's the AXI protocol. We'll learn there. Okay. We won't learn USB controller. It is not part of your front-end verification training. Okay, once you complete your course, you can once you get into a course, when you get into a project, in your project, what things you are working on, that specific protocol you need to learn. That's how the learning is. It's not like everything we learn and then we'll get a job. That is not possible, because learning is very too much is there. So what you need to do, learn the basics, get into a company, and in your project, what work you will do. Suppose if you are working on USB work, you learn USB protocol that time. Is it clear? Okay. Yeah, any questions? So here it happens through PCIe. So again, in your project, we're coming across something called a PCIe project. If you're working on a PCIe project, or if you're working on a DDR projects, then you have to learn DDR protocol, DDR protocol, PCIe controllers, all those things you need to learn there. Based on your job profile, you need to learn the new technologies. Okay. So I hope everyone understood this analogy of electronic system. Okay. The use case also I have explained to you. We have also discussed regarding the drivers as well. Just now we discussed it. When USB device is connected to laptop, the meaning is you purchase a laptop from Amazon. Let's say you will purchase a laptop today. You will go home, purchase a laptop from Amazon for your. If you have a laptop, you would already have it. But if you don't have, you will purchase it. So you will purchase it from Amazon. Let's say for example. So what will the Amazon will deliver your laptop? You will open it in the QS. You will open it, and you want to watch a movie. First day itself, you want to watch a movie. So what you will do? You'll insert your pen drive, and you'll see that your laptop doesn't detect that pen drive only actually. Then will you? Then what you will do? You'll be in a panic mode. I bought my new laptop for 50,000 rupees, and the pen drive is not working. Yes or no? That panic will happen because in that excitement, you will get panic even more faster when something doesn't work. Now the reason is it is not because of your laptop faulty. It might be because the laptop drivers might be outdated. So what you do, every new laptop, right, you will get that first update actually saying that update your OS or update your system, something like that you will get. When you do that update, right, what happens? All your drivers in your laptop, keyboard drivers, display drivers, USB drivers, etc. All those drivers will get updated into the latest versions so that it will be compatible with your pen drive, etc. Is it clear? So when USB device is connected to a laptop, USB device gets detected. When we start doing transfer to USB device. So USB device is nothing but what? USB drivers are nothing but set of assembly level instructions which controls the USB related hardware behavior. So what is a driver? Driver is nothing but the assembly level instructions which controls the hardware behavior. That's it. Here is a USB. Such way keyboard drivers, display drivers will be there. Embedded system engineers develop these USB drivers, generally done using embedded C language. So does bus driver manufacture the bus? Tell me, let's say here outside there is BMTC bus. Okay, now will the BMTC bus driver manufacture the BMTC? No, right? They won't manufacture it. Similarly, VLSI engineers will not manufacture the USB drivers. USB drivers development will be done by embedded C engineer, embedded system engineers. What we are responsible for? We are only responsible for the USB controller hardware behavior. Understood? So how bus driver is responsible for bus operation, bus acceleration, bus stopping, all those things. Right? That's the bus operation, right? Bus hardware operation. Is this clear? Okay. So this in this slide we are just showing you how a complex SoC architecture, generic SoC architecture will look like. No, I'm not saying this is what the architecture Qualcomm uses. This is not the architecture Google or Samsung or etc. product companies who manufacture their processors use it. This is just a generic. Okay. So here, what all you see here? CPU subsystem. What CPU subsystem has? It has 4 A7. A means what? ARM Cortex. ARM A profile Cortex 7 series processor. There is here 2 A15. Again, it's a ARM A profile. A profile in the sense what? Application profile it is. This A profile is what goes into your mobile phone also and laptop. A15 series processor. There are 4 here. There are 2 here. Okay. And we are having something called as here this is called as a cache, and this is called as cache interconnect. So all these are present inside CPU subsystem. Okay, then we are having design specific subsystems such as GPUs, DSP subsystems. Then we are having something called as application IP subsystem. Some encryption subsystems we are having here, AES encryption, MPEG. Then we are having memory subsystems where we are having different types of memories, LPDDR, wide IO memories. Then we are having subsystem interconnects, nothing but high speed wired peripherals such as USB, PCIe, Ethernet MAC. These are all high speed peripherals present. PCIe will be used for your communication with your SSD in your laptop. Okay, USB, USB just now we discussed about USB, right? Then we are having something called as wireless subsystems, Wi-Fi, GSM, LTE modules. Then we are having something called security blocks. In every SoC will be having a security blocks which are meant for authenticating your informations, fingerprint information, for example, or eye retina scanner information. Your mobile phones nowadays have what? Retina scanners, right? Retina or facial ID. That authentication blocks will be there. One of the example for a security subsystem application is a retina scanning and authentication. Okay, one example. Okay, so this is how a typical SoC will look like. So a front-end engineer can end up in either, once you learn the basics, right, you can either end up in a SoC verification where you will be part of verifying entire block, entire SoC. Meaning what? CPU does the transactions for the USB. Does the CPU initiate transactions? Does it reach till this point? You will verify it using a test bench built using UVM. Is one example. Getting my point? A verify means once you complete this training, you can end up with SoC verification. One thing. Second is what you can either be put into IP level verification. IP level verification means what? Verifying USB controller only is what is called as IP level verification. Understanding? Or else you might put into subsystem level verification where you will be verifying this particular subsystem block. What is the subsystem? Memory subsystem. This houses DDR controllers, houses wide IO controllers. Right. So you might come across this verification or a IP level verification or a complete SoC level verification. Is it clear? Do you have any questions? Types of verification, I just discussed about the types of verification. All of these three types, common thing is what? Verilog, system Verilog, digital, and UVM. It's a common thing. Do you have any questions so far? Online, offline?
No.
Okay. I'll add one more point also. Now to become an IP level verification for USB controller, what you need? You need SV Verilog digital knowledge, UVM. Additionally, you need a USB controller knowledge because it's the USB block you are verifying, right? Getting my point? So additionally, you want a USB controller knowledge. If you are doing a subsystem level verification, what all things you need? You need Verilog, digital, system Verilog, UVM. Additionally, you need knowledge of DDR controller, different types of memories present, DRAM, SDRAM, those types of memory, different volatile memory, non-volatile memory, knowledge, and wide IO peripheral, wide IO controller knowledge you will be needing. What is meant by 5 layer? You should be knowing. These are the additional things. But basic is what? digital circuitry, Verilog, system Verilog, UVM become the basics. Suppose you got into a complete SOC verification. Again, the common thing, the basic all you'll be needing is digital, Verilog, system Verilog, UVM. Additionally, knowledge on ARM processors, basically processor, RISC-V processor or ARM processor, you should be knowing. Means RISC-V or ARM, again based on where you are, which company you are working for. There is a lot of factors present here. Understood? SOC verification is done using something called as a C-level language, because this ARM processor will understand assembly level code. So you will write a C code. C to assembly conversion is taken care of by the ARM linkers and compilers. So this ARM generates the transactions using AXI bus, for example, to the USB controller. Understood? Additionally, what you need, additional knowledge what you need is the ARM architecture, ARM instructions, or RISC-V architecture, RISC-V instructions. Is it clear? These additional knowledge which you need to, means my point is, what additional knowledge you need, it will be based on which domain you are put into in the verification. It might be very SOC level, it might be IP level, it might be subsystem level. So what you get, that expertise you need to achieve. Means what job you get, that expertise you need to take responsibility of achieving it. No one will come and tell, hey Nitesh, you please read USB controller verification. No one will come and tell in industry. If you want in-depth knowledge, you need to learn it. So as a VLSI engineer, our learning is a right. It will be on every day-to-day basis from today onwards for you guys. Every day you will be learning something new, and you have to be open to learning also. Is it clear? Yeah, please tell me.
Hi,
Do you
sir.
have any?
So, yeah. So, I just want to understand. So, here we're going to understand the whole architecture and the basics things, right? So, what you said just now that depend on our project, and yeah, we need to learn the additional things, right?
Yes, yes.
Okay, okay. All right. Thanks.
Yeah. So this front end course will not give you the complete. See, what I'm trying to do is the front end training is there, right? Or design verification training will not give you the exposure to this SOC architecture here. Means what is interconnect, what is this A processor, what is this GPUs, what is this memory, all this information you will not get in a front end fresher level training. What you will get, you will get the basics, which is present in a SOC level, IP level, or a subsystem level. When you get into when you get job, when you get a job description, or after you get a job, you will put into some project. That project will tell you which domain expertise you should be achieving. Okay, understood? But I would like to inform one more also. VLSI Guru also has additional courses such as SOC level verification course where RISC-V processor we verify. VLSI Guru also offers PCI controller verification, DDR controller verification, memory controller verification. Right? You see here, all those things are here itself. Memory controller, DDR controller, LPDDR controller, USB controller, PCIe, Ethernet MAC. You will learn Ethernet MAC in your as part of your training. Ethernet MAC you will learn, but PCIe, DDR, USB, these things, if you want to get the expertise, this, now, the next 8 months is not the time. Once you get into a project, then you need to think over it. Okay, give me a minute, I'll connect my charger. Yeah, any other questions you have? Okay, fine. Let's go further. This we already discussed regarding how SoC processor USB controller is present, right? Electronic system drivers use case. Again, this use case also we have discussed. That I think here they are discussing regarding screen off time actually. Means the screen off after 30 seconds you want to make it off to save the power saving modes it's called as. See your portable devices such as mobile phone and laptop, they're all portable. Washing machine, it is not a portable device. It will be there as it is, right? You cannot carry washing machine everywhere. Yes or no? That's not possible, right? So they're all not portable devices. Projector also is not a portable device. Okay, for projector, washing machine and all, constant power supply is needed. So apart from them, laptop and mobile phone will be having something called as a low power verification. Even that is also a part of front end verification only, low power verification. So what is low power verification in the sense? Basically to save power. So your mobile phone, you might want to keep the display off time after 30 seconds or 60 seconds or 1 minute. Some people can also keep it as never also. Never means what? Display will never turn off until you hit the power button. So we are doing all these things because to save the battery of our mobile phone. Yes or no? So when this 30 seconds screen off time is there, your battery will come maybe 1 or 2 hours extra, right? So this is one use case scenario. Okay. So I just told you something on low power, right? So front end engineers, with respect to SoC, I will tell you SoC. There is a concept called low power SoC low power verification. Okay, so basically we have to put our processor into a low power mode or a sleep mode. Okay, now again this SoC low power verification, again it's not part of your fresher training because as a fresher it's not needed. As a freshers, what is the expectation is the basics should be thorough. Low power is all about which domain you are put into, low power or IP level, subsystem level, like that. Okay. Fine. VLSI engineers understanding requirement. So what you need to understand here in all the electronic system what we discussed so far, what you need to understand. As a VLSI engineer, you need to understand how the hardware works. Example, as I told you, suppose let's say tomorrow you are put into a IP level verification. I am just saying an example. Let's say once you get into a project, you are put into a IP level verification where you are working on a piece USB 3 or USB 2 IP. USB 2 you won't work now. It's USB 3 or 3.2 IP you are working on. Let's say you need to be having in-depth knowledge of the USB 3 IP. If you don't have, you have to get it. Is it clear? Hardware, how this hardware works. When you know how a hardware works, then only you can develop a verification to that. Then only you can verify it. Do you agree? Yes or no? Now it's like what? No, it's like an example. What I'm trying to give you here is it's like you want to go from Bangalore to Chennai. You need to know how to go from Bangalore to Chennai first. Meaning what bus to choose, what are means of transport, bus, train, or plane. Yes or no? If you don't know that only, and if you just say that you want to go from Bangalore to Chennai, how will you go? Not possible, right? Yes or no? So understanding of the means of transport, how much time it takes, which is cheaper, based on that you will decide whether to go on a plane, bus, or a train. Yes or no? All those knowledge, if you have only, you can choose the right thing to travel. Yes or no? Okay, right? Similarly, you need to know about an IP, about a hardware before going to the verification. Because verification you would have learned in your basic training, Verilog, system and log, UVM, digital and all. Okay. Hardware understanding should be present. So how firmware interfaces with hardware, that is how the driver interfaces with the hardware. Basic understanding on how firmware works with the hardware is sufficient. In-depth knowledge on hardware operation is needed for a VLSI engineer. Basic understanding means what today, whatever you understood in terms of a driver, that is sufficient. Okay, that is what is called as basic understanding. In-depth means what? Deep dive into the hardware operations. So VLSI engineer don't need understanding on operating system and applications. You don't need to worry about Windows operating system understanding and all. Means how to develop the code, all those things you don't need to worry, because it's not a VLSI engineer role. Okay. So I hope things are clear here. Okay. So we'll take a break. Okay. We'll take a break for 15 minutes. Assuming now it is 11:20. We'll take a break for 15 minutes. We'll meet up at 11:35. Okay. Same class. You guys can come offline. Online, you can be in the meeting, or you can drop off and you can join the same meeting link for the online. Is it clear?
Okay.
Yeah. Sure. Thank you.
This conference will now be recorded.
Yes, sir, you're audible.
Okay, let's continue with our session. So we were discussing regarding electronic systems in VLSI, right? I hope it's clear here, right? And what are the different types of verification you can perform. Next, let us understand regarding VLSI design styles. Designing of a VLSI electronic system, what are the different designing styles are present? Two major styles are there, only two major styles are there. That is, one is ASIC flow, second is FPGA flow. Okay, so ASIC, right? Okay, before going to that, what is VLSI? VLSI stands for very large scale integration. What are we integrating? Transistors we are integrating. Since we are integrating billions of transistors in current scenario, it's called as very large scale. Okay, now there are two major styles of developing a VLSI chip. There is ASIC and FPGA. ASIC means what? Application specific integrated circuits, where the hardware is developed for specific application only, such as mobile phone chips or laptop chip. FPGA means what? Field programmable gate array, where same FPGA board can be programmed to behave like a different applications. Okay, different applications they can behave as. Give me a minute, okay? Yeah, FPGA, field programmable gate array. So where same FPGA board can be programmed to behave like different applications. Okay, so like same FPGA board, it can be used to behave like a mobile phone also, and it can be reprogrammed to make it as a laptop as well. That is what is called as FPGA. Now for ASIC designing, right, we use Verilog. For FPGA designing, we use VHDL. Okay, we use VHDL. So which one looks better? Just by definitions, if you see, right, which one looks better? FPGA looks better, right? Because it can be reprogrammed and made it to behave like a different applications. Though it looks like FPGA approach is better, however, industry prefers ASIC design flow due to low cost of manufacturing. See, for FPGA, right, cost of manufacturing will be more compared to ASIC. Why? Because ASIC chips are developed in a mass production. It's not like mobile phone is built on hundreds, right? Suppose let's say Samsung S26 mobile phone has launched. So that mobile phone is not manufactured in only 100 numbers or 1000 numbers. Do you agree? It is manufactured in lakhs basically. Mass production. Yes or no? So because of which ASIC, see, you as a basic rule, anything which is manufactured in a mass product, mass manufacturing when it happens, cost of that particular product will be what? Less. Do you agree? Yes or no? So now question comes, if ASIC is cheaper, why we don't use ASIC to do everything? So why? Because ASIC, right, initial investment is very high. Meaning what? To set up the manufacturing unit for a ASIC, it is difficult. Difficult in place of money. Why? Because lot of engineers people have to hire for designing, verification, front end flow, nothing but front end flow plus the back end flow. Okay, so for ASIC, initial investment is very high. For FPGA, right, initial investment is less because FPGA boards are readily available. Okay, yeah, is it clear? So cost of ASIC design flow, basically multi-million dollars to set up the design flow from the scratch till the end. So once flow is working, right, once the flow is set up, once the investment of multi-million dollars is done, cost of manufacturing of the ASIC chip will be less because it's a mass production. Cost of FPGA design flow, initial investment is less since hardware is readily available. Per chip manufacturing cost will be more because of less production is present. Okay, so I would like to keep it till here regarding ASIC and FPGA. Okay, because we don't need to go more in how much per chip cost is there, all those things. Even though they have discussed it here, I don't want to go detail. Okay, what you need to understand is what is FPGA, what is ASIC. For FPGA, what do we use? Designing VHDL we use. For ASIC chips, we use what? Verilog we use. This much is sufficient. Okay. So they will discuss regarding per chip manufacturing and all that we don't need, right? Because we are not developing anything. Okay. Let us go through ASIC design flow. Basically, ASIC design flow, right? There are two types of design flows present: front end domain and the back end domain. Okay. So this ASIC design flow analogy, it's like house construction. Okay. So when you're about to construct a house, you will be having a land. Let's say 30 square, 1200 square feet is the land dimension. So what will you start with? Will you start with directly house construction? No. We'll first start with what requirements. Basically, you will provide your requirements to the architects. Meaning what? There'll be house architects present, right? You'll provide it to them, saying that you want 3 floors. Each floor should be having 2 BHKs, right? Like the requirements you'll be giving. For the house architect, input will be the requirement from the customers, that is the landowners. Output, what the architect gives is an architecture diagram with various plans like electrical outlets, how many floors are there, where the washroom, bedroom, kitchen should come, like that. The house architect will give you the plan, right? Then what you will do, you will give this plan to the masonry or contractor, right? You will be having contractor person present. That for the contractor, the input will be the house architect document. So what contractor will do, he will see the plan. Based on that, he will get the materials. Yes or no? Then output is what he will contractor will build a building. What according to the plan, contractor will build the building. Next comes the plumbing, who does the water work, means plumbing work into your house, electrician, carpenting, and last comes the painter work. Then the house gets finished actually. Overall, right, how many people will be there? 50 people will be there. You think that overall put together, starting from house architects to the painter, 50 people are involved in constructing a 1200 square feet dimension house. Similarly, how the ASIC design flow also works similarly to this. That is, the ASIC design flow overall consists of 15 steps divided into two major categories. The two major categories are front end domain and the back end domain. In the front end domain, it starts with a design requirement. Okay, like design requirement in the sense, what are the features you want in a SoC, which goes into your laptop or your mobile phone. That features is the design requirement. That is given to the architect. What will the architect do? Like how the house architect develop the plan on a paper. Similarly, the SoC architect or VLSI architect will take the requirements and develop a plan, saying that what are the blocks to be chosen, how it to be placed, how much power its consumption happens, all those things. Architect will come up with a plan. RTL designer will take the document from the architect and develop each blocks, designing using Verilog. Each blocks gets designed. After integration, he connects multiple blocks to form a complete SoC. Like how you saw memory subsystem, IPs, and all, right, in the earlier slide. All those things, connections, the integration engineer will do, and a complete chip is designing is done. Later on comes the verification, functional verification, where engineers will use their skills such as digital design, Verilog, system Verilog, UVM, to develop a verification environment or verification test bench for the given design. Okay, understood. So this is where our job role comes under functional verification training, functional verification. Next, we do DFT at Verilog RTL level. DFT is nothing but directed test cases. Okay, so where some test patterns, ATPG test patterns are applied to the design to check its behavior. So front end overall has how many steps? Design requirement, architects, RTL design, RTL integration, RTL function verification, and DFT at Verilog RTL level. So to become a RTL design engineer, you need to know, to become an RTL design engineer, or you need to become an RTL integration engineer, you need to know Verilog and system Verilog and digital very thoroughly. You need to be knowing in digital concepts. You should be very good in it, and system Verilog and Verilog. So to become an functional verification engineer as a fresher, you need to be knowing digital, Verilog, system Verilog, UVM. Okay. So DFT is a different course. Overall put together, DFT is a different course. Okay. Where if you, for designing, integration, and the function verification, you need to be having skill set. What is the skill set you need to be having is basically no skill set. the skill set should be interest to perform coding. Interest should be there to write the code. That is it, the skill set. Even if you don't have skill set on digital design, you will learn it in the course. You will learn it from the basic to the advanced. You will learn in the digital design. But what skill set you need? Interest to learn. Okay, so I'll address the questions. Sumitra, yeah, please tell me, do you have any questions?
Yes, sir. So, so ASIC design engineer do RTL design, is it?
Yeah, I will tell you. ASIC RTL design engineers, they will do the RTL designing, means Verilog designing they will do.
Mhm. Digital design engineer, RTL design engineer, both are same, sir.
Yes, both are same. Digital design engineer, RTL design engineer, both are same. Basically, that name is different because based on the companies, the name will vary. Okay,
Okay, so
but both are
basically they do.
yeah.
Basically, they do Verilog coding, is it, to implement specific application?
Yes, Verilog coding, strategies to implement that code, all those things they'll be responsible for doing.
Okay, thank you, sir.
Yeah, anything else? Strategies in the sense to optimize the circuit. Okay. Okay, shall I continue? Okay. Uh, yeah, as I was telling, DFT is a overall a different course. If anyone is interested in, you can enroll for the demo session. They will teach you in detail about what is DFT. Okay, DFT at RTA level, DFT at gate level. Okay, so what is, I'll tell you difference. What is the job remains the same. DFT at Verilog level, Verilog RTA level, DFT at gate level, both the jobs remain the same. The only thing is the RTL file in terms of front end, it will be in terms of Verilog code. In terms of back end, it will be in terms of gates. Transistor level, it will be there. The RTL code. Okay, that happens in the back end first step, that is synthesis engineer. Synthesis. You would have come across RTL designing plus synthesis. You would have come across some job roles also. What the synthesis does is it converts RTL into gate level. That's it. Again, synthesis, it's not like we are going to write the things from the scratch. Gate level implementation, it's not, that's not how we do it. Basically there are tools present. Design compiler is a tool present. One example is design compiler, which converts the RTL Verilog code to equivalent gate level. Okay, now after doing conversion, there are some set of checks present. Logical equivalent checks is what we call it as. It is done in synthesis stage. All those checks should be passing. That is what the synthesis engineer will take care of. Then comes the DFT at gate level. Again, DFT at Verilog RTA level and the gate level is both one and the same. So there will be only one engineer which will take care of both the operations for a project. One or two engineers maximum to minimum one in a project. Next comes the physical design. Again, physical design is also a separate course which VLSIGuru offers. As part of a front-end training also it is there. You can enroll for the separate course. Okay, for demo session you can enroll for it. You will get to know what is physical design. To understand what is physical design, enroll for the demo sessions. Okay, so I am focusing only on the functional verification aspect. Okay, so why we can't do everything? Because time is restricted, right? Because we have only 3 hours, we need to cover everything. To be covering is not possible. Then comes STA, static timing analysis, custom layout, physical verification, GDSSI extraction. Basically, it's a file extraction process, fabrication, post silicon validation, and packaging. So these are the different backend domains present, and these are the front end domains present. Okay, so here what happens is physical design engineer or physical design engineer only takes care of physical verification, GDSA fabrication, all those things. PD itself will take care of it. Post silicon validation is again different course present, validation course. Okay, now to choose a front end, what is skill set required? Interest to learn, obviously, interest to do the coding. These are two skill sets. Skill sets for backend domain is lot of theoretical topics will be there. Lot of theoretical topics will be there. So you need to be open to learn theory. To getting my point. Front end is theory plus practical. If 100 theory topics are there, 100 practical will be there. It's a one-to-one mapping. Meaning what? In front end, if you learn about a topic, that same topic theoretically you will experiment and you will get to know. So coding will become easier. To do all those things, interest should be there to code. That's it. And if you don't have interest, you cannot you are not eligible. You cannot do front end training if you're not having interest. So front end is 90% code, 10% tool. The tool is for simulation. In terms of backend, 90% is the tool, 10% is the code. Where the 90% tool is what the scripting you will use. TCL scripting you will use for interacting with the tool. For that, you should be knowing the theoretical knowledge of op-amps, CMOS, FinFET, all those things. Which Kirchhoff laws, all those things, it will be trained for you in the backend course. Is it clear? So in the backend also we are having basics and advanced. The basic you learn all the means op-amps, the current laws, all those things you will learn. Okay. Do you have any questions here? So if you ask me, sir, how can I choose a front end or a back end? It will be lying on one simple answer. If you are interested in a code, choose front end. If you are interested in, if you're not interested in code, choose back end. Interested in coding, choose front end. Not interested in coding, choose back end. That's it. Okay. Now when it comes to job role, right? When you are interested, you will be able to ace a subject. Do you agree with me? If you are interested in a thing, you will have that curiosity to learn new things. You will have that curiosity to do the things. Yes or no? It's like, suppose you want to go for Chennai for trip vacation. Not Chennai, it's too hot. Think of as let's say Uti. You want to go to Uti for vacation in this summertime. It'll be chill there a little bit. So what you'll do if you're having interest in vacation, right? What you'll do? You will explore a lot of new places, plan your schedule, right? So that you won't miss anything. You'll have that curiosity, you'll have that interest. You'll involve yourself very much and you will do that. Yes or no? What is the end result? Your trip will be very successful. Means you'll be able to see a lot of things, create a lot of good memories, get a lot of Instagram posts. Yes or no? Right? So if you have curiosity, if you have interest, if you have that uh, learning to a goal, then you will be able to ace the subject. So that's the reason I'm telling you the skill set required. Having an interest to learn, go with front end. Having an interest to not to do coding, if you don't have any interest to do coding, choose back end. Okay. Any questions?
Yes, sir. So in this course, are we covering this RTL design and RTL integration, or it will be focused only on RTL functional verification?
See, main focus will be functional verification.
Mm-hmm.
But in Verilog, right, you will learn what is designing, how to design a module. You will learn it there. What are the rules present? All those things you will learn in Verilog. Integration also you will learn it. Okay.
Okay.
See, again, design and integration is not only learning Verilog. there is something called as LEC checks. Means basically theoretically, when you go, clock domain crossings will be coming across. You should be knowing what is clock domain crossing, what is reset domain crossing, how do you tackle that. All those things you need to be thinking that those are the additional things in RTL design and integration. Okay, so those things it's not part of this course, functional verification course. There is a separate course present. It's called as RTL design plus integration. You can inquire about that in the VLSI group. Okay.
Okay, sir. Thank you. Yeah.
Yeah. Yeah. Anything else? Questions you guys have? Okay. No questions. I'll go further.
Can you hear me?
Yeah, I can hear you. Yeah. Tell me your
Sir,
name.
yeah, I'm Monish.
Yeah. Please tell me, Monish.
Yeah, but I couldn't understand the RTL concept. Can you please elaborate? Just RTL. What's the work of RTL in ASIC?
Okay. Okay. Got it. What is the purpose of an RTL? Right. Got it.
Yes.
Okay. See here. I guess you have previously I explained you something called as a USB controller. Do you agree, Monish?
Yes, sir. Yes, sir. I mean.
Right. So where we saw that USB controller operation is what we understood. We understood that
Yes, sir.
basically to
Yes.
interact with our peripheral. This is a port, USB port. Where using the
Yes, sir.
port, there might be pen drive, there might be printer, etc.
Hmm.
So the data communication to happen from SOC to the peripheral, we use USB controller. This USB controller is nothing but a design. It's a design. It's a module. It's a block which is written using Verilog. Now, what is written using Verilog? That operation saying that what the command, what the USB need to send to the peripheral, either to read the data or write the data. The rules, basically the rules.
Okay.
Understood. So that
Yes.
rules, how do you, I mean, I am saying rules, right? I am saying some features, I am saying some rules. It should be how it is implemented actually. It will be implemented using a code,
Yes, sir.
synthesis
Yes, sir.
codes, Verilog code, right? That is what is called as
Yes.
RTL code.
Okay. So basically, we are trying to write a code to how to conduct a communication between two devices. That's right. Am I correct?
Yes, exactly correct.
Okay, sir. Thank
Exactly correct. Yes.
you. Okay.
Okay. Fine. Yeah. And integration is all about this is called as integration. Like this USB 3 controller, it is integrated, meaning what connected to the SOC system on chip in this high speed wired peripheral subsystem. Basically, there will be one block present called as high speed wired peripheral block. It's again a module. That module will house different blocks such as USB, PCIe, Ethernet in our example, which are meant for high speed wired connections basically. High speed wired connections from SOC to external blocks. See, PCIe is used for your SSD operation, SSD in your laptop. That storing and writing happens through PCIe itself. PCI Gen 5, you would have come across your laptop, right? SSD one terabyte PCI Gen 5, you will come across it. Specification when you purchase a laptop. Do you agree? Yes or no? When you purchase a laptop, when you see the SSD configuration, what will you see? 512 GB or 1 terabyte PCIe Gen 6, Gen 5, that you will see.
Yes, sir.
Higher the generation, more faster is the reading and writing to the SSD. Okay. Fine. Yeah. So what I'm saying is integration is all about integrating a specific IP such as USB controller into a subsystem to build a bigger block such as SOC. That is what is called integration. Again, there is some Verilog rules present to do that. Verilog syntaxes, Verilog rules are present to do that. Okay. That is what is RTL integration is all about. Basically, the RTL designer will only take care of integration also. There won't be separate engineer for integration in terms of RTL. The designer itself will do the integration. Okay. Fine. So let's go forward. So we discussed this front-end domain flow. See, basically, just comparing the VLSI front-end domain flow with the software front-end domain flow. See, VLSI, right? Front-end domain is similar to software. So in software, right, means software engineers, what they will do is they will be knowing C, C++, Java type of languages. What they will do, they will be getting, and they should be good at reading the software specification. Meaning what? Suppose some product they are going to launch, some software, some application they're going to launch. That application specification they should be able to read and understand. Once you read and understand only, you will be able to develop that algorithm. In software point of view, we call it as algorithm flow or flow chart, you call it as, right? That algorithm flow will tell you what are the steps required, what are how the step is present to achieve a particular scenario. And what will the developers do? Developers use the algorithm and use the C, C++, Java language to develop that algorithm. So front-end domain flow in terms of software engineer, they should be having good programming skills. In terms of VLSI front-end engineer, right, means if you're looking for a front-end engineer job, you should be good in Verilog, system Verilog, UVM. You should be good in programming or having inclination towards programming. You should be good in reading hardware design specification and understanding the design specification. This is what you will achieve. This is what you will achieve. That is, reading the specification, understanding the specification is what you will achieve in this front end design and verification. These chapters, that is AXI, Ethernet MAC chapters. This is a real-time project, as I told you, Ethernet MAC, where actual design will be given to you, actual design specification will be given to you. You need to understand the design specification. We will have a sessions to go through the design document line by line, understand the design document, and develop a verification environment for that. Understood? For both of these things. Okay. So, and implement requirements using various protocols, using USB, PCI, DDR, AMBA protocols, etc. Okay. So software doesn't require any backend flow. So software, you don't develop any hardware out of it or any physical equipment out of the software, right? So there's no something called the backend flow. So what is backend flow? Process of converting the Verilog RTL code into a chip is what is called as backend flow. Meaning what? Process of converting the code, Verilog code, into gates is what is called as backend flow. Now, not only conversion to gates, also once the gates are converted, once we get the gate logic, right, that gate logic need to be verified actually and placed on a silicon. That is what backend flow is all about. Okay. So in VLSI, the functional verification plays a very important role. The reason is, if the reason is here in VLSI, right? This domain plays a very important role actually. I am a functional verification engineer. This becomes a very important role for me. Why? Because if anything, if any particular feature is not checked properly in the design, that feature can have a bug in the backend flow. After synthesis, there can be some bug present here when they verify it. Understood? Now, if they verified it saying that there's a bug present and the RTL functional verification engineer has not verified it, then what will happen? Again, it has to go back to here. Again, it has to go back to the stage and do everything from the scratch. Sir, no. Time waste. These engineers are spending extra time. Company has to provide extra money. Yes or no? So our role in functional verification becomes very crucial. We have to make sure that each and every functionality of the RTL design is verified thoroughly. Okay, how we do it? By developing robust test bench using UVM, system Verilog, and digital concepts. Understood my point? So if there is a bug in the chip which is detected once it is production, customers are using it, bug cannot be fixed. Suppose even the PD engineer also forgot to verify it, it will go into my laptop. Let's say that bug is present in the, okay, it will go into my mobile phone. Let's say bug is present in my camera. I have purchased 1.5 lakh mobile phone and camera is not working. Will you purchase that mobile phone? Will people purchase those kind of mobile phones? No, right? Now why it's not working? Equipments are there, but that equipment is faulty. Camera is present, but the camera model is faulty. Right? So you won't use it, right? Why to waste 1.5 lakh on purchasing a faulty equipment? So in software, right? If there is a bug, what they'll do? Suppose let's say software, let's say your Android iOS Android software, right? They launch a new software. Let's say next month, March 4th, they launch a new software. You all will install that software. You found out that software is draining too much of battery because of some feature of the software. So what the software people will do? They'll not do anything. In the next month, they'll create one more software called as a patch version 2, 2.2 versions like that. They'll create it, which where that patch will fix that issue. That operation cannot be done on a hardware. That patching, it cannot be done in a silicon. Once silicon is present, once the chip is manufactured, you cannot go and put a bandage on it, right? If a feature is not working, you cannot do that. So verification is a very important role. Okay. Coming to job roles present in VLSI domain, I'll speak with respect to both front end as well as the back end. These are how the mappings are present. For design requirement, we call it as marketing team. For architects, chip architect level, this architect will generally be a 15 plus years experience, not a fresher role. RTL coding, integration, function verification are mapped as RTL design engineer, RTL integration engineer, functional verification engineer, and DFT engineer. The DFT engineer will take care of both RTL at DFT at RTL level, DFT at gate level. And these are the backend job roles which you can see in your LinkedIn profiles or Naukri, etc. Synthesis engineer, formal verification engineer, DFT engineer, physical design engineer, STA engineer, layout engineers, physical verification engineer, fabrication, PSV engineers. Okay, these are the job roles you should be looking into. If you chose a front-end domain, if you choose a verification domain in front-end, you should be looking into this job role. Okay. Any questions? Till here, do you have any questions? Okay. So this is how a engineer count will differ. We will be on a ASIC SoC project, mobile phone SoC project. So front end and back end there will be equal number of engineers. Architect will only be one or two basically. Designing team spread across 4 to 6. Verification 15 to 20 will be there. So what you have noticed is 30 to 40 percentage of the times we are having job roles in front end as function verification, in back end as PD engineers. PD or STA both knowledge will be acquired. Both only one engineer is sufficient to do basically. Okay, this is how the number is present. Do you have any questions? Yeah, any questions? Online, offline, do you have any questions?
Sir,
No.
excuse me.
Yeah, I didn't get your name.
Sir, Monish here.
Monish, yeah, please tell me.
Sir, my question is based on for placements. This question is regarding placements and all. So,
Yeah.
for which roles freshers are being hired in VLSI domain?
See, basically, VLSI Guru is offering training in every aspect. Design
Oh,
also openings are there. Function verification also openings are there. PD also openings is there. DVFT also is there. STA also is there. Layout also is there. What you
okay, but I'm
choose?
asking in general. No, I'm not asking about VLSI group specifically. Yeah, I'm
Okay.
asking in general.
No, in general, see, it's all based on the market situation, right? It's all based
Hmm.
on market situation. It's not like every month, every time they'll be hiring every engineers. It's not like that. Okay,
Okay.
based on the requirement, openings will be present for each domains.
Hmm.
Every
But
domain
VLSI
opening is there.
will provide a placement for most of the roles like design team, functional verification, and DFT and all.
Yes, yes, correct.
Yeah, okay.
Okay, fine. I'll proceed. So you have any questions?
Sir, if we join the course, we need to know the minimum basic, or in the course
Uh,
only start with basics.
See, the point is you don't need to know any basics. If you, I told you skill set required is what? Interest to learn is a skill set. To choose VLSI, interest to learn VLSI. To choose front end means interest to code. Choose front end. Interest to, if you don't have interest to coding, then choose back end. That is what I'm telling you. Okay, interest only. No prerequisites. Why? Because everything is start from the scratch. From the scratch to advance, we'll be teaching you. Okay. And we'll also help you to develop your English speaking skills, confidence level building. All those things will help you in the soft skill training. I told you, right? Soft skill training will happen there. Only thing is what? You are paying money and enrolling it. You have to take that initiative to attend it also. Soft skill training mainly. Getting my point? because
Yes, sir.
whatever your money you're spending, it's including the soft skill also, right? So you have to take that initiative to join it. You should not be like, oh, I'm nervous. That is there to remove that nervousness only. Soft skill training is present to remove that nervousness, scared to come on the stage, right? Remove it. For people online, I know you can't come to stage, it will be on virtual. You have to open your video cam and explain a topic. That will be the soft skill. What online it will happen. For offline, you have to come to stage and you have to explain the topic to the soft skill trainer. Topic will be not some complex topics like issues in current politics, not like that. Economic system, not like that. Very basic topics will be there. It topics might be related to your subject oriented only. Many times we are not doing any debating in terms of soft skill training. It's just sharing your thoughts. That's it. Sharing your thoughts, coming to stage, sharing your thoughts front of like front of a 10 people. That is what is main focus on, where your confidence level, nervousness will go, and speaking skills will be improved. Okay. Yeah, please tell me, one of you had a question.
Yes, sir. I just want to understand that for backend and frontend, just now you tell me that we need to understand. I mean, we need our interest to learn the coding, right? So,
Yes,
may I know after our class, and suppose once we complete some kind of the RTL design chapters, so after that we have some practical hands-on, which is similar to our industry project and something.
yes, I will tell you. Yes, Verilog, right? You
Yeah.
will do theory. First thing is we learn theory. That is the basics. Is what Verilog is divided into two things: basics plus projects. So in the basics, right, what we'll do is we learn theory. Theory means what? Data types, how to write a function, how to write a module, all those things. We will not only learn to theory, but also do labs. Where in the labs you have assignments. Assignments are done. Assignments done for for theory topic. Now question comes, sir, okay, sir, I will learn these things in theory. Verilog I will learn, but in industry, how it is applied practically? That is
Correct.
where projects come into picture. I think that's your question, right?
Yeah.
That's where projects come into picture. So where in every SOC, right, there is something called as FIFO present. Every real-time project will be having something called a first in first out memory. It's nothing but a memory, actually memory. You will practically learn how this FIFO memory is implemented in Verilog in a real-time project. Now, this again, two variations are there. One is synchronous and asynchronous FIFO. Both of these things you will learn. Understood?
Okay. Yeah.
So one example I just gave you here. One example I just gave you here. Such way you are having these projects, right? If you go through here, mm, here, if you go to here, you're having the okay. This is deep dive of Verilog. Verilog design and verification using multiple projects. You have counters. FIFO also is there here, right? FIFO, synchronous FIFO, asynchronous FIFO, finite state machines. How do you implement state machines in a Verilog? That is that every sequential circuit has a state machine present, right? How does state machine is implicit state machines, explicit state machines? How do you define it? All those things will be taught. Okay, basically you can go through this thing here. They'll teach you. They here it is listed down. What all things you'll be learning. Okay.
Okay, sir. Thank you.
Yeah. Thank you. Yeah. Anything else? Same thing in terms of
So,
test bench
hello.
development as well. Give me a minute. Same thing in terms of test bench development as well. Industry standard test bench. How it is present. How you develop it is what you will learn in AXI, UVM topic, AXI, Ethernet back. Okay, yeah. Now please go ahead. What is your question?
So we can see that there are AI tools everywhere and automation is taking place. So can we see any automation or AI tools even in this domain, especially for this DV role?
Okay. See, as of now, right, AI tools are only able to solve compilation issues actually. Meaning what you have see my company has an integrated AI present. They have their own AI. Okay, so my company what it is doing is when you have any compilation issues at the it has come now means 1 month back only it got integrated this AI into the workflow. Okay,
Okay.
so what it is doing now is it is able to compilation issues. Compilation means what, you know, right? What is compilation?
Yeah,
Like
yeah.
some files are not included or something issue is there in the file, syntax issue, something like that. You open Gemini. Hey Gemini, this is the error I'm getting. This is the output log file. This is the directory. If I put it, my Gemini will tell me that yeah, this is the issue. You can change this to this, it will say. What I will do, I'll open the file directly and change it to the suggestion what the AI has provided me. Compilation only as of now. What I know is it'll still take another 10 years minimum to get some full flow. But in verification aspect, it is all about strategies. It will be dynamic. I'm still not, I mean, according to me, that full strategy AI cannot do by itself.
Okay.
There should be some engineers present.
So there
Okay,
is still
now
hard coding being done.
what might happen is number of engineers will reduce, but still engineer will be there when
Okay.
AI comes into full fledged. Okay, yeah, yeah. Please tell me you had some follow up question.
I mean, is there still hard coding being done still? That is what I was asking.
Yes, hard coding is still done, but in scripting aspect, that is scripting. You know, scripting, right? Python scripting aspect.
Python.
It is automated. Means you ask Gemini, it will give you an output. Now for that output, you still have to see Gemini or any AI tool will not give 100% output. There will be still errors. 10% error will be there. The 10% error is where you need to jump in and you need to fix it.
Okay. Okay.
Okay, so what happened was 1 year back, if to develop a script, if it took 30 minutes, now to develop a script, it will take only 10 minutes.
Mm.
Where 50% to 60% tool AI will give me, remaining 40% is what I need to check, correct it. That's it.
Mm. Yes.
Understood? Okay, yeah.
Okay.
Anything else?
No, sir.
Okay. So we have discussed regarding job roles. See, DFT point of view, you please enroll for DFT course. Training schedules, basically. Yeah, let's me discuss regarding training schedules again. Now, as I understand this demo session, there are two categories of candidates which are going to enroll. One is pursuing engineering, completed engineering, and you have time in the weekdays. Monday to Saturday, you are having time, right? That is called as on live session, live session training, where candidate will attend the training session lively, either to online or offline. Like online means the GoToMeeting, how you guys are attending the demo session in from your home using GoToMeeting, you're attending demo session, right? It's a live demo session. Offline, we have an institute present. Facilities are there in offline, internet facilities. You can sit and you can explore the things, and you can yeah, offline means you have a facility to come to the institute, attend the face the trainer face to face, and attend the training, like how the offline you guys are attending a demo session, right? So that is on live session, that is online plus offline. Second is what? Online mode. Now this live session training, it is meant for meant for Monday to, it will be from Monday to Saturday. Like, okay, means people, you are already computer engineering and looking for a job. This training is, live session training is what is helpful for you. Online mode is for, online mode means for working professions. Professional. Meaning what? You guys have already working in a domain. You want to switch to functional verification domain. You might be in a software domain, switch to VLSI domain, like that. So where you don't have time to attend from morning 9 to evening 6 in the institute. There comes the online mode actually, where topics are pre-recorded, and it is latest topic, latest videos, means latest contents is what I'm trying to tell you. Every a month or 2 months we'll be revising our videos actually, so that it will be up to date with what is there in the current what is following. Okay, so topics are pre-recorded and latest videos are present. So access will be given module based, means topic based. Meaning what? First digital access will be given. You have to go through digital topic in your own convenient time. Oh yeah, thank you, man. Yeah, thank you. Yeah, so what I was saying was, online mode is present for working professions, where topics are pre-recorded and latest videos will be there. Access will be given topic based. Once you complete, let's say today you enrolled, okay, first digital topic will be given to you. You have to watch that video in your own time. Meaning what? It's an online, right? But there will be limited duration, like 1 month duration. In the 1 month you can watch it in your own time, either in morning, evening, whenever you're free after your work is completed, or whenever you find time, you can watch it in your own time. Okay, that is online mode. For both live session training as well as the online mode, the same PPT will be followed what is present in the portal. Course access will be the same. Mode of training will be what is a different. Digital, same assignments will be there for online as well as the live session. Nothing will change. Nothing, even a word will not change. PPTs followed is all same. Just the mode of training is different. Understood? Okay. Anything else? Yeah. See, for live session, right? For live session, recording also will be given. Recording in the sense what? Not the online mode recording. Every day live session, what happens? That recording will be given. Now, why this will be given? Suppose, let's say, one of you have missed the session. One of you are absent because you were having some issues. You were absent on the day when I was teaching Verilog topic. One topic, let's say data types. You are absent. That data types chapter, which was recorded on that day, access will be given to everyone of the live session training for the next 10 days, so that you can go through it and prepare. Is it clear? Okay. Will be given recording for live session, recording of live session topics also will be given. Access for 10 days. Suppose today I taught Verilog data types. From today, the next 10 days, the access will be given for that specific video. Now, that video access cannot be given within a minute. Meaning what? Now 12:30 I will end the session. 12:31 you won't get the access. There is some process present. It is the process from the GoToMeeting application actually. So it takes minimum 6 hours for the recording to be available for us to download then re-upload to the InSkill server, means our website server, where you can watch the videos. Okay, that time you can say that within a day it will be given. One day, within 1 day time frame, the video will be uploaded. You can think 24 hours. Is it clear? Yes. Study materials, regarding study materials, right? PPT is given, but the study material booklet, right? The hard book copy, you have to reach out to the institute once you do the enrollment. Okay, you can ask during enrollment itself, you can ask for them to provide the study material. They will give you online plus the offline also. Means some of you might be not in Bangalore. Let's say you are in Kerala or Tamil Nadu, like that. For you also, the book will be given through postal. It will be sent. Okay, but all those procedures, right? I am not aware of it. The procedure I am not aware of it. You please reach out to VLSIGuru Institute admin. Okay, they will tell you the procedure what is present for receiving the books. Okay. Anything else? Weekend sessions. Even I've heard that weekend sessions will be conducted for doubt clarifications mainly. So again, reach out to the institute on the. I'm not see again in the weekends, right? If there are, we also need some candidates actually. Like we need some 20 or 30 plus candidates. Then only we can do a weekend training. For 1 or 2, we cannot schedule a weekend because we need to allocate trainers and all, right? So based on the number of count present on a weekend, based on that the batch will be decided. Till now it didn't happen. No one was ready to for weekend actually. Everyone were in either live session or an online itself.
So we can switch from live to online.
Yeah, you can switch whenever you want. Suppose you got some job and you want to switch from live to online, you can do that. There won't be any additional cost, and pricing wise both are same only. There won't be anything additional and all. Okay, you can just procedure wise, you please reach out to institute. They have some procedure present, some form filling and all is there. You need to do that. What is that procedure? You can ask them. See, I am only on technical aspect. Non-technical procedures and all, you can reach out to admin for helping you out in that. And one more thing I would like to add up here, because this is a very common question what I see in every demo sessions. The common question is, sir, I am having less CGPA, will I be able to get a job? Because in your engineering, it's all about CGPA. You get a higher CGPA, you are put into the hiring recruitment process. Now you are completed your engineering. Now you are in a institute for learning things. In institute, we are already tied up with the organization, the companies. Okay, so what we can do is, what we will do is, if you are having potential, if you are showing that potential, even though you are a just pass person and you're having that potential, that you are able to understand the things and do the things of the topics what we are teaching you, if you're able to show that potentials in the test evaluations, mock interviews and all, we will push you into the we push you into the industry. But the point is, you need to prove it. You need to prove that you are having that potential to crack an interview. You have to prove that actually. How will you prove it? How will you prove it? Evaluation. Basically on evaluation, day to day, even day to day trainers will evaluate you. You might not know it, but every day trainers will evaluate you. Okay, how they evaluate you? By asking questions, by observing your behavior, all those things we will do. Okay, understood. And one more thing, no institute will tell that 100% placement for a candidate. 100% placement will only happen if, when trainer gives 100%, where if in a VLSIGuru institute or any institute gives 100% from their side on the subjects matters. If a student also gives 100% from their side, then only 100% placement is possible for a student. Suppose if a student is not doing anything, he's just roaming, not attending sessions, we don't know what he's doing only, There are people, there are candidates who are saying that they have enrolled, but I have never seen them in my session, in my class only actually. And admin asked me saying that, is this person present in your class? He asked me actually. I'll be like, no, no one is there in that name, because I don't see him in online every day. I don't see him in offline every day, right? Do you agree? And when their parents ask us what we will do, I will say no, they're not there. Those kind of candidates we cannot help in getting placements. Practically not possible. Do you agree? Yes or no? When you don't attend, when you don't learn, how can we provide placement? Not any institute cannot be able to provide the placement. Okay, keep that in mind. Okay, keep that in mind. Yeah. Anything else? Yeah.
Sir, how will they evaluate in online?
Same thing, test will be there, mock interviews will be there, face to face, live videos, means how a real virtual interview will be there, right? Like how, see, now I'm not asking the online guys to on the webcam and all, but in a real mock interview or a real interview, your webcam will be on, your screen will be shared, and the questions will be asked. Even though in the written test you might do cheating, but in that mock interview you cannot cheat.
Or that online mode?
Same evaluation for the live session training or the online mode is the same thing only. Mock interviews, uh, face means live session means live interviews will be there, and tests will be conducted. Okay, mock interviews which will be live means what? Face to face, you should on your webcam share your screen, all those things, that and all is there. Assignment wise, job putting you into the job support group, that procedure and all, everything will be same in terms of live session training and online mode. Evaluation will be the same. Only thing differs is what? The live session training means lively, I and you will be present in a day, we'll have a session in live mode. Online means it will be pre-recorded videos, that's it. Subject wise same, support wise it's the same, evaluation wise it's the same. At the end both of you will be put into the same job support group only. Meaning what VLSIGuru job support group is present, same job support group only it will be there. What opportunities offline, what companies live session training will reach, the same companies online mode also will get. Okay, that is the same thing. Only different is the mode of training is different, that's it, to accommodate the candidates. Okay. Yeah, anything else? So how the assignments given will be compared to the real work in the companies? See, Prashant, tell me, Prashant, I'll ask you one question. Like, see, Verilog, right? You're learning regarding languages. You won't learn languages in company actually. Getting my point? You cannot relate assignments to a company level questions. You cannot relate that. It is practically not possible. For the projects, you can relate it to company level. That is possible. Getting my point? When you're studying something, you study basics. System Verilog, you study System Verilog language. That System Verilog language company guys will not study, right? They'll be studying, they'll be doing real-time project. That project similarities is what we are having in our VLSIGuru projects. Ethernet MAC, UVM AXA project, and Verilog projects. That you will have, not with respect to subject point of view. Subject assignments, it is purely for you to get a 100% grip on the subject. Project point of view, real-time application is a project what we have. Okay, I hope it is clear, Prashant.
Yes.
Yeah. So follow-up question is, let me open that. Will the project also be covered? Yes, projects also will be covered in this course. You can go through this link. Okay, list of projects are present in this link. You can go to this link. Like Verilog design and verification multiple projects. AXI, this is also a project. AXI protocol is a project actually. Okay, protocol means what theory will learn, plus that protocol will implement in the project, in the code, real time. It's a real time actually. Ethernet MAC is a project. Okay, Ethernet MAC is a very vast project actually. It's a real time. See, you see, I have showed you one Ethernet block in the SoC architecture, right? Here there is something called Ethernet. This is that Ethernet MAC project. This is that Ethernet MAC project, what you saw in the course. Okay, this verification is what we will be doing. Okay, anything else? Okay, if you don't have any questions, I will wind up our demo session. Okay, fine. So let's hope. See, I'm actually a part of a front-end trainer in VLSIGuru. I don't come every day because I'm actually working professionals. I am doing teaching as part of interest. Okay, so I will be. Let's see that. Let's hope we'll see each other in the upcoming modules, right? Of front-end verification. So basically, I will handle UVM and AXI. Okay, so let's hope that we will meet in future. Okay, thank you everyone. We will end this demo session. Okay, thank you.